Here we go, grand finale, 6-2, finally going to move on, but we got to tackle these 4 sample problems from your packet, and then you shouldn't have too hard of a time with your homework problems that are similar to this. Now, the only thing I didn't show in the pre-lesson was there are parts. These are a little bit more complicated. So, first thing I want to say to you is break them up into bite-sized pieces. So we got the square root of 18 times the square root of x squared. This should jump out at you as super easy because it's a perfect square root. This, we go, aha, been there, done that. Square root of 9, square root of 2, and this just turns into x. So, what is the square root of 9? Well, that's 3. Now I'm going to go ahead and bring that x in the front, and then throw the square root of 2 on the end, and that's appropriately written for example 15. See, that's not too big of a deal. Now we've got this. Now things are going to be a little bit more connected to the pre-lesson. So we got the cubic root of 375. We've been there, done that. What's the largest perfect cubic root that goes into 375? 125. How many times? 3. Now's where it's going to get interesting. You see, we also have the cubic root of a to the 5th. Now think of it this way. Remember we said bottom bigger, bottom bigger, bottom bigger? Well, this is not in the bottom, so we're going to make it smaller. In other words, what's the first number less than 5 that 3 goes into evenly? And I hope you're thinking 3, because you're right. How many would be left over if I took 3 a's away from 5? 2. Notice this is a perfect cubic root. This is a perfect cubic root. So we're going to tackle those first. Cubic root of 125 is 5. What's 3 divided by 3? That's just 1. So it's just a, or a to the first, however you want to write it. And then we're going to mishmash these things back together. So it turns out to be cubic root of 3a squared. So we break them up into individual parts. We figure out where the perfect cubic roots are, and then we mishmash the stuff that doesn't get simplified. Okay? That's kind of the gist. Now we have a problem here. We have a denominator. But look at that. That needs to jump out at you. That is a Christmas gift. Take it. Open it. Enjoy it. So what's the square root of x squared? X. Don't let that mess with you. Take care of it right away. Now, we also have the square root of y cubed down in the denominator. Now, if you watch the pre-lesson, you got a little annoyed by me saying bottom bigger, bottom bigger. Well, that's the point. I want to annoy you to the point where you memorize it. See, there's an index of a 2. What's the first number larger than 3 that 2 will go into? 4. So what I want is the square root of y to the 4th. Well, what do I have to add to this? I just have to add a square root of y to the 1st. Then I got to add square root of y to the 1st. I'll take care of the top. I got some oil here, and I got some water, so don't you dare mix those. But then, by multiplying these two things together, I get this. Now I can divide the 4 by the 2, and I get y squared. And then I'm done. All right, example 18, last one. Again, I referred to this as a Christmas gift. There's a Christmas gift right here. What is the cubic root of 27? Well, that's 3. So we're going to take that and just put it in our answer. So I'm just going to fill stuff in one piece at a time. Now I can see in the numerator, I've got the cubic root of a, and that is just going nowhere. Now what I'm going to do is break off a piece, It's like a cookie. And you don't want to eat the thing all at once, so you break pieces off. So I'm going to look at the cubic root of 4 in the denominator. This is going to take you back to previous things that I taught, and it's sitting right here. Remember when this is a perfect square root? I said help yourself out and write it differently as the cubic root of 3 times the cubic root of 3. Then you only have to add one more in order for the roof to fly off. We're going to apply that rule to this problem. So we're going to make this the cubic root of 2 and the cubic root of 2. Why? Because 2 times 2 is 4. But why would we do this? Because now, remember the rule, if you cube a cubic root, the roots fly off. So if I add a cubic root to the bottom, I got to add one to the top. I'm going to multiply 1 times this. So I get the cubic root of 2. And then if I cube a cubic root, the roots fly off. So there we have it. Now, I'm going to take this, and I'm going to join it with this eventually. But for now, I'm just going to highlight this and highlight this. Because there's one more thing that I need to attack. And that is the cubic root of b to the 4th in the bottom. So I have 1 over the cubic root of b to the 4th. Now, my little jingle should start hitting you. Bottom bigger, bottom bigger, bottom bigger. What's the first number bigger than 4 that 3 will go into? And you're thinking, I hope 6. In other words, I want the cubic root of b to the 6th because 6 is divisible by 3 and this equals b squared. So I got to create this down here. How? I got to add the cubic root of b squared because this times this gives me this, and that's what I want because that'll get rid of the radical because it just works out. But if I add that to the bottom, I also have to add it to the top. So this crazy thing will be the cubic root of b squared all over. Now watch this. This times this gives me this, which reduces to this. So it's just b squared. So I have 3 different chunks of pink that need to slam together. I'll just put that over 1. So if I put this all together, I'm going to have to use this space over here. So look at, this is in my top, this is in my top, this all is in my top. So if I multiply this by this by this, I would get 3 cubic root, put the number first, 2, then alphabetize it, a, b squared, all over. Now, stuff in my denominator, a 1, a 2, and a b squared. So I'd get 2b squared. That is a pretty challenging little math problem, no doubt about it. All right, well, good luck on your homework assignment. Let me know if you have any questions. You are to do, oh boy, let's see here. Yeah, there we go. 16, 17, 18, and 19. You can call her good.